And we are better than ever. Today we are talking about variation, and we happen to be talking about direct variation. That's the first type of variation that we will talk about. A lot of formulas are based on variation equations. In direct variation, the values of the two related variables increase together or decrease together. So as something increases, if we're on an XY plane, as one item or one component increases, the other increases as well. It could also be that as one decreases, the other decreases as well. And these relationships are always linear. Okay? Distance equals rate times time. That's a good example. If this were distance and this were time, with the blue line, as distance increased, time increased. And as with the pink line, as distance decreased, so did time. So that relationship is linear and is known as direct. Probably best learned through examples. Here is the main equation for direct variation. If a variable y varies directly with a variable x, then y equals k times x, where k is the constant of proportionality, or the variation constant. We will use constant of proportionality when we talk about it. Okay? K is the constant of proportionality. So let's try an example. The resistance of a wire R varies directly as its length L. Write an equation for the resistance of a wire R if the constant of proportionality is 0.008. So what we'll do to start off with is we'll just write the generic equation, the general equation. Okay. Y varies directly as x. Okay. And K is the constant of proportionality. Well, here it says R varies directly as its length L. So we're going to place Y with R. It varies directly with L. And we have the constant of proportionality, 0.08. So I'm going to replace K with that. And that's all there is to it, 0.08 times L. So that's no big deal. Is it always going to be that easy? Of course not. We're going to have problems to solve with direct variation. Here's another example. The recommended dosage D of the antibiotic drug, I don't know how to pronounce that, is directly proportional to a person's weight W. Write this variation as an equation. Okay, so we have D varying directly as W. So Y equals KW. Okay, and we'll just read it carefully. D is directly proportional. D is the one that's directly proportional, so that's going to be, it's going to replace Y. And that equals K times, oops, this should have been an X, right? And Kx, that's the general equation. And we're going to replace the X with a W. So that's all there is to part A. Part B, find the recommended dosage in milligrams for Doug Colzer, who weighs 192 pounds. Assume the constant of proportionality for the dosage is 18. Okay, so this is just very simple. So the constant K is 18 times 192. And if you take 18 times 192, you get 3,456. And that is in milligrams, so mg. How do I know it's in milligrams? Because they told me right here. So no big deal at all. Okay. Example 3, finding the constant of proportionality. Suppose y varies directly as W varies directly as the square of y. So before I read anything else, I'm going to write that out. And I'm not going to read, I guess the general form y equals kx is good, but I don't want to put it down here because y is involved, and it's not involved in the same way that it's involved here. So let's just write it straight out. Y varies directly. Why do I keep saying that? W varies directly. So W equals, if it varies directly, there's going to be a constant of proportionality K as the square of Y. Well, that is y squared. Not the square root, the square. This is how we represent a square, y squared. If w is 60 when y is 20, find the constant of proportionality. So let's see, 60, if w is 60 when y is 20, equals k times 20 squared. So 60 equals 20 squared is 400, so 400k. And I divide both sides by 400. And let's see, remember, if we're dividing by 10, that becomes a 1. And so that's 6 over 40. The 400 over 400, it cancels because 400 over 400 is 1. And let's see, we can simplify 6 over 40 to 3 over 20. So that is my constant of proportionality. Okay. You could also write it as a decimal. That's equal to 0.15. By the way, that was my party call. That's kind of creepy. Sorry. All right. Last example, using the constant of proportionality. The area A of a picture projected on a movie screen varies directly as the square of the distance D. The area A is, or varies directly, so there's going to be a K, as the square of the distance D from the projector. Okay, that might be important. It's from the projector, so that's K D squared. Okay. If a projector at a distance of 25 feet projects a picture with an area of 100 square feet, what is the area of the projected picture when the projector is at a distance of 40 feet? Okay. Well, basically they're asking what is the area of the projected picture when the projector is at a distance of 40 feet. So let's start with that. Well, I know that A equals KD squared. Okay. And I have to solve for, and I know the distance. So, we're going to dismiss that. We're going to dismiss that. Sorry about that. Okay. So I know the distance. That's 40. So I can replace that D with 40. And I'm looking for the area. It's asking me what is the area. So I'm looking for A. Well, the only thing I need is K. Well, how can I find K? Well, I can find K with this first bit of information. If a projector at a distance of 25 feet, so I'm going to use this equation here, so that's K times 25 squared, projects a picture with an area of 100 square feet. So when this happens, the area is 100. I'm going to replace A with 100. So if I know this, I can find K and then replace K here. So 100 will equal, 25 squared is 625. That's not a good 5. 625K. I'm going to divide both sides by 625, divided by 625. And I will tell you that K is equal to, as a decimal, to 0.16. You would be able to use a calculator for that. Okay. Well, now we'll play a little Pac-Man. And we are going to replace K with 0.16. So 0.16 multiplied by 40 squared. So A is going to equal 0.16. 40 squared is 1600. And so the area will be 0.16 times 1600, which is equal to 256 square feet. How about them apples, ladies and gentlemen? I hope you like apples, because those are some good apples. That is all I have for you today. Hope you enjoyed it. We'll see you next time. Becker is out!